excited and we are encouraged by the number of people that are interested and engaged in this topic. And let me just give a brief introduction and overview, and then we'll go into the first panel. The way the meeting will run today is there's a first panel that's a University of California panel. Second panel, then there will be two speakers, one from Microsoft and one from the Women in Data Science Conference. And then the second panel will have speakers from CSU and California community colleges. A few announcements from my side. So first of all, this community got started through the national workshop that we hold every June. And we're just getting ready to organize it again for next June. But you can sign up for information about the national workshop in June. We will have a panel from this group, again, convening at the June workshop. We will be putting more details out there about how it's organized over time. If you are new and are joining us from community colleges, this is a great place to learn about how to teach a fundamentals of data science class. And there's a lot of material that's for new instructors to adopt things. If you've been to that workshop, maybe give a little wave right now, just so you can see, like, there's other people on this call that come to the workshop and have, learned through and participated, and a great place to create community. We also have a Slack that come out of that workshop. So if you're interested in being on a Slack and asking questions to each other from this community, there's a link to the Slack. There's also a survey that we're doing on people that have adopted the Data 8 materials. And the Data 8 textbook writers want to get feedback from people who have adopted Data 8 at their institutions. It's 5 years of the inferential thinking textbook, and they want to do, a rewrite and sort of get your input. And we're also looking to get more material, like when people make up new homeworks or labs for their university or institutions, we're looking to create community and get more material shared around that, because we really think this is an interesting way where other people will bring in new data sets and examples for teaching, but that are fitting into this common framework. Second, I always want to use this forum to share opportunities. And so our human context and ethics team has a new grant about training for people who are interested in teaching human context and ethics. If you're interested in leaning into this community, there's a toolkit that's built about teaching that's called the HCE Toolkit. They have a grant from Mozilla Responsible Computing, and they have a new grant about doing workshops. So stay tuned for information about that. You can also email hce@berkeley.edu if you're interested in participating in one of these trainings over the coming months. Please reach out to those folks if that's something that you're interested in. Finally, for some of the new people, where is this coming from? Who is this group? Who are these people? So we had, a meeting at the national workshop that was held in Berkeley, where we did some brainstorming and some talking about what are people interested in. And we had many different participants from California institutions at different levels. Some of this is bureaucratic and infrastructural. We're really interested in facilitating articulation. So how can we help new instructors articulate their classes? How can we help people get their classes listed? We're really interested in, inclusion and broadening participation. How can we get as many people from as many backgrounds as involved in this new project of data science and data science education? We're interested in sort of internships. How can people connect to industry? We've had many discussions about that. And how to reach out and not just be in CS and stat, how to reach out to different parts of your university. We've also had discussions about infrastructure. We have different ways that we're piloting infrastructure that might go across organizations. Is this a pathway that we're going to build into the future? So anyways, this is coming out of you know, different meetings that we've had with key stakeholders, and sort of like, what are ways that we can grow to the community, and what are ways that we can start to meet the needs of the different participants by our participation. So with that, I would like to move on to the first panel on the different UCs and what's going on there. And there's been other fora for this in the past, especially through the Moore Sloan initiative. But I think things have really moved quickly, and it's really nice to see like an overview of how things are happening at different UCs. I'm going to introduce Deb Nolan, who will be the chair for this panel.
Okay, thanks, Eric. I'll put the link to the slide deck also if you'd like. Some people like to follow along sort of separately. So I'm Deb Nolan. I'm the Associate Dean for Undergraduate Studies in the Division of Computing, Data Science, and Society. And I'm also a professor in the Statistics Department. And I oversee, as part of my role as the Associate Dean, I oversee the major in data science and the minor in data science. And today we're going to hear from 4 different campuses. We'll hear from UC San Diego, UC Santa Barbara, UC Riverside, and UC Irvine about the development of their data science programs. And in addition, at the end of this slide deck, I also put information about our data science major as well, although I'm not planning on giving any presentation about the Berkeley data science major. It's there more for completeness for us to see a spectrum of the various data science majors. So I'm hoping that this will be a way for us to share our different approaches to our majors, and what are some of the challenges and future directions that we're going in. So with that said, let's just start with the UC San Diego, and Professor Justin Eldridge will be giving a brief introduction to what's going on in San Diego.
Thanks. Yeah, I'm happy to be here. So at UCSD, we have an undergraduate major and minor in data science, and our programs are housed within the Halegiolu Data Science Institute. And the fact that we are within an institute and not under a college, for example, the College of Engineering, does have an impact on how we run our program. So to give you some context, HDSI has both faculty that are 100% appointed in HDSI, like myself, but we also have a lot of people with joint appointments from across campus, from computer science, math, political science, all over the place. And all of these people who are involved in HDSI in some way must teach in our program. Specifically, they have to run a capstone. And so I'll talk a little bit more about the capstone in a second. As far as the size of our program, we have 820 majors in our capped major and 170 minors. And our major is about 3 to 4 years old, depending on who you ask. And our first graduating class was last spring. Okay, Eric, next slide, please. So this is sort of a schematic of how our curriculum is laid out at the moment. So on the left is our lower division, and the foundation, the bedrock of the lower division is DSE 10, which we based on Data 8. One difference between our DSE 10 and Data 8 is that we decided to teach pandas itself as opposed to the data science module, and we developed a restricted subset of pandas, which we call baby pandas, and is taught in 10. And then the curriculum kind of splits off into 2 parallel tracks. On the right is the programming track, where students learn data science, or data structures in Python, and then in 30 they learn Java. And then on the left is the theory track. I like to call 40A baby machine learning, and then 40B is baby algorithms. And then all of that kind of culminates in DSE 80, which is a class about data science, the practice of data science. I kind of view it as our lower division capstone. It's sort of a sequel to 10 in some ways, and it's a great class for preparing people to do data science in the real world, to do internships and so forth. In our upper division, we have classes in different areas, of course, systems, visualization, machine learning. We have 4 elective tracks. These are sort of prepackaged sets of classes that students can take in different areas, but they can mix and match classes between areas. And then we have a 2-quarter senior capstone. So this is where we really leverage the diverse backgrounds of people within HDSI. So any faculty member associated with HDSI is going to lead a capstone group. And that group is generally 5 students, 10 students on average. And in the first quarter, they replicate a paper. They pick a research paper and try to reproduce the results. And then in the second quarter, the students create their own project with related ideas. Okay, next slide, please. And so some of the challenges that we've identified, one of them is just staffing some of these core classes that are somewhat specialized. So for instance, we have classes in data management and distributed systems, and it's hard to find someone to teach that every quarter. This is a core class, so we need to teach it a lot in order to get our majors through to graduation. But we only have a small number of faculty who are capable of teaching that class. So that's sort of the bottleneck that prevents us from growing. And just in general, there's sort of a tension between time to graduation and then viewing data science as its own distinct discipline, right? So at the start of the program, we shared a lot of courses with computer science and math, but as time has gone on, we have more classes that are distinctly within the data science major. And this presents some challenges. So one is that we don't have any room to add any more required courses. So one of the things is we'd love to teach more linear algebra in the lower division, but we can't add a course in linear algebra for data science because it would put us above our cap on number of required courses that we can have. We can't specialize some of our courses like we might want to. When we teach Python, we're teaching it in a general way so that we can accept transfer credits for Python. And as a result, we have these long prerequisite chains. Next slide, please. And so long term, we have several goals. So in the spring, actually, our plan is to do a sort of data-driven review of our curriculum. We're 3 to 4 years in, so now we have some feedback and we can kind of think about what's working and what isn't. So some specific things that we have planned to think about. First is greater support for those without programming background. So we see in our intro classes that there's a bimodal distribution, and I'm sure everyone sees this, between students who have some programming background and those who don't. And we've seen also transfer students disproportionately struggle in DSE 10. And so we need to find a way of supporting them. We'd love to find a place for more linear algebra and stats in our lower division. We'd like to rework our machine learning curriculum. It was kind of out of necessity based on what computer science offers, but our students have a different background and maybe we can be a little bit more advanced in our machine learning curriculum in the upper division. We're trying to find a permanent place for ethics and critical reasoning. This is sort of distributed through our curriculum right now, but we're trying to find a place to maybe make it a required core course. But again, we're limited on how many core classes we can offer. We want to shorten those prerequisite chains and standardize the teaching of tools throughout the curriculum. And one project that we have ongoing is the development of what we call a data and society minor. We kind of recognize that our existing minor is too large for anyone to take unless they're in engineering or in a technical area. And so we'd love to offer a minor that focuses more on, issues in society and prepares people for being citizens in this century.
Thanks, Justin. We have a minute, I would say. If anyone would like to ask Justin questions right now, you can either raise your hand or type it in the chat. If anyone has a question. How many faculty do you have?
That's a complicated question because we have 2 full-time teaching faculty. We have 3 lecturers, and then 100% faculty in HDSI, the number is growing. So, and then we have a bunch of 25% faculty. And so like HDSI, the core group might be like a dozen, but beyond that, we have several dozen people associated with the Institute.
Great. Another question is, what are you looking for from your community college transfer students?
Yeah, I mean, so we, of course, work with community colleges to articulate classes similar to DSC 10. And I guess it's a tough question because DSC 10 has no prerequisites. It's our intro class. And so we don't really ask for anything there. But we do see that people who have a programming background definitely are more set up to succeed, right? So if students have taken some programming, it's great.
There are several more questions, and I'm going to keep on time. I'm going to make sure I keep track of all these questions, and I'd like to have 10 minutes at the end for us to be able to go through all the questions. So I apologize for those of you who raised your hand, but I will, if you could please just type your questions in or raise your hand again at the end. Next up, we have Professor Mike Ludkowski from UC Santa Barbara.
Thanks, Deb. So I'm Mike Ludkowski. I'm the chair of the Statistics and Applied Probability Department at UCSB. So UCSB is still in a transitional state as far as our vision for data science is concerned. We have our first generation effort is existing statistics and data science major, which was originally called statistical science and was rebranded as in 2018. So it still is essentially statistics and data science added on. And that program grew enormously in the last few years. We now have close to 800 majors. And just to note that our department, statistical probability, actually has 2 other programs inside it. So this is even a subset for us. On campus in general, the efforts for data science are led by CS, which is in the College of Engineering, and ourselves, we are in the science division inside the College of Letters and Science. So we are somewhere halfway through to get to the end state, which I'll have in the next couple of slides. A major step we took was we started with this data science core project last year. So this year is the first year we're actually running it. So this is in partnership with Cal Poly, Cal State San Bernardino, and Santa Barbara City College. And so this is one of the really huge benefits for us is to be able to talk to Cal States and to the city college to have a sense of how to build the transfer pipeline and think about preparing students not necessarily to UCs. So part of that project is we have now data science fellows. This is the first year we have them, so it's about 25 of them. They're supposed to be juniors. We have a mix of juniors and seniors this year. And our main goal was to have a really diversity of students to become data science fellows, so not necessarily just coming from CS or stats. That remains a challenge for us in terms of having students prepared. The main goal of the project is to have capstone. So this is a year-long capstone where in falls it's a prep class. I'm covering everything from ethics and fairness to how to work on a large scale project. And then winter and spring is actual capstone projects. So we have 55 students involved this year, 13 different projects, sponsors coming from industry, all kind of data science startups in Santa Barbara area, several campus institutes, a couple of nonprofits. So it's a really diverse group. The students were basically ranking, they got presentation on the sponsors and they were ranking which projects they want to join. So that seemed to work out really well. Again, we're still in the growing pains of working out those logistics because this is the first year it's running. Otherwise, we have quite a lot of classes which have been created by different departments, essentially ad hoc. Last couple of years, we've been really focusing on creating the data science 1 and 2, which is kind of inspired by data 8, which is the data science for all effort on the breadth angle. And then both CS and statistics have a lot of advanced classes with long chains of prerequisites. And then we have been quite successfully engaging other departments in terms of using Jupyter Hub. So we have now instructors from political science, economics, linguistics, and so on. There's close to a dozen instructors this quarter using Jupyter Hub. That's been very useful to connect. Next slide, please. We have several challenges. One of the challenges is the college structure. The College of Engineering, which is the College of Letters and Science. Also, both statistics and computer science have been really heavily impacted. And there's a concern with the deans about just having even more students, we already have a hard time handling the students we have now. On that angle, the College of Data Science does not have any admission by major, so there's really no way to cap a new program. And this has been one thing that's been kind of slowing us down as we try to develop the data science major. We have the vision of scaling up significantly our lower division courses, data science 1 and 2. Of course, that requires buying in from the departments that would count it as an elective or a general education. So that's a lot of legwork in that direction. We have some progress, but we're kind of in the early stage of doing that. We don't have any dedicated space for data science right now. We're not a big campus, but computer science and statistics are kind of on opposite ends. So as for now, we're working with the library to use their facilities. And just generally having the infrastructure to take on non-CS, non-statistic students to take those classes, anything from undergraduate learning assistants to having higher TA ratios than the campus usually used to scaling the capstone and having this pipeline of the capstone. This is some of the challenges we're working through. Next slide. So where I'd like to end up is having a dedicated BS in data science. So this proposal has been submitted last year to the campus, and it's under review. And the idea would be an inter-departmental, inter-college program. This is the first one on our campus. So this is one of the challenges that this is a new thing for the campus to do. And the way we see it is there'll be a core, which is built out of CS, statistics, and math, and then 3 different emphasis areas, broadly speaking, humanities and arts, environmental sciences, which are really strong in TCSB, and social sciences, with 3 departments in each emphasis area. And so this is 12 departments involved total. So this is really a sort of a campus-wide effort, and we've had a faculty advisory board from all those 12 departments talking for about 3 years now. So the way we see this is going to work out is to have the breadth courses covered by teaching stream faculty, and we are actually well on our way to do that. So we've hired several teaching stream LPSOEs in the last couple of years, and there's more hires on the way. So this is already moving well. And then the next building block would be to have joint hires, roughly speaking, 1/3 FT attached to data science program, again, which is just standalone program, not affiliated with any department or college, and then 2/3 in the connected department, any of those 12 departments. So that's what we hope to have in the next 3-4 years. In the interim, we managed to fundraise close to $3 million in donor funds to start expanding and building the instructional activities for the next couple of years. And so that's been our way, is essentially to have, while this proposal is being considered by the campus and all the deans and so on, we already have pretty much all the infrastructure in place in terms of the classes created, the curricula developed, and thinking through all the pipelines and having the department buy-in. Once this is in place, on the horizon, we have also data science minor, as well as graduate level kind of breadth data science training that already was introduced last spring by Sango in our department. I think that's all I have.
Great, thank you, Mike. That sounds really ambitious. Everybody's being great about keeping on time, and we have a minute to take just a couple of questions. And Jamal, I see your hands up, but was that a question? Was that a question for Justin? Or do you have a question for Mike as well?
Yeah, it was for Justin. I'll wait for the end.
Okay, great.
Thank you.
While we're waiting for people to type in questions in the chat, I have a question for you, and that's about this. I'm quite intrigued with your 10 joint hires, where 1/3 are in data science, and it sounds like data science is not an actual department, but you're talking about it being sort of inter-college. How does an entity like data science, you can actually hold FTE?
Yeah, so we have a couple of problems like this. They're not inter-college, so this is a new thing, and that's why it's a little bit takes some time to convince the leadership on campus. But we have, for example, interdepartmental program in marine science, which has a similar setup. So we can have programs which hold FTEs, and especially on the teaching stream, it's pretty straightforward to do. on the research angle, it's less so. So in that sense, on the ground, it will be that the connector department is the one holding the majority of the FTE, and therefore that's the place to have merit and promotions handled, and then data science is a fraction.
Great, thanks. Let's just take one more question for you. Will UCSB being housed in the library mean some shared computing lab space with existing library facilities or any other synergies?
Yeah, so our library has what's it called collaborate spaces, which are for interactive learning. And that's a new space. Our library had a large expansion about 3 years ago. And so that space continues to be available sort of on a ad hoc basis. They're not having full utilization themselves, and so they're happy to work with us. In the meantime, it's not clear how stable this is going forward. But yeah, so they have labs, and they have really nice facilities actually.
Great, thank you. Why don't we now go to Riverside? So Professor Miriam Slalom, if that's how you pronounce it, will be talking to us about the data science at Riverside.
Great, thank you. So we have a new data science major that is housed across colleges, the College of Engineering and College of Natural Sciences, and across two different departments, statistics and computer science. And we recently launched this program in fall 2020, but with a very small cohort. There was some delays in the program approval, so it was not officially open for enrollment, but we were able to convince some students to change into the data science major. So we have currently a small cohort of 19 students. But we've received large number of interest for the upcoming academic year, and we were happy to note that we have a better diversity in the applicants compared to our computer science major. Our program requires 42 quarter system courses. Students are accepted into a college. So they either accepted into the College of Engineering or the College of Natural Sciences, and their degree will be from that particular college. And so then they were required to complete their GE requirements based on their respective college. In addition, they have a set of computer science courses, statistic courses, 2 sequence courses in an application area that is outside of statistics or computer science. For this program, we wanted to make sure that we didn't, in the beginning at least, we don't create too many new courses, but we did feel the need to create 4 new courses for our program, 2 in computer science and 2 in statistics, to fulfill the current gap. In the future, we foresee that we will be introducing additional courses. But the 4 new courses that we proposed was a lower level data analysis methods where students use Jupyter Lab, do process data, use APIs, do data cleaning, look at data visualization. And then a big data management course where they are working with big data platforms, Hadoop, Spark, learn about NoSQL databases. And then 2 courses in statistics. On the next slide, I have a snapshot of our course plan. So you can see that we have an existing course in technology, policy, and ethics. And in the future, we envision introducing a new course in data science ethics. We have a set of math requirements. And then we pulled out courses from computer science and statistics, as well as the new courses that we had proposed. And the 2 courses in application area. And these are 2 courses that could be in biology, economics, or so forth, in which they build upon the data science skills that students have acquired. In terms of the challenges that we faced, we faced a lot of delays in getting the program approved. We started this process in 2016, and the program was not approved until 2019. But going forward, in terms of the challenges that we anticipate, recruitment is one issue we're trying to strive for, creating welcoming flyers and advertisement for the program so we can reach a diverse group of students. And the second challenge is that we currently require data science students to take the same set of intro computer science courses as CS majors, and we do note achievement caps due to prior experience. So we may need to create a new sequence of courses for our data science students. Our long-term aims is to introduce more courses to satisfy our 2-sequence application area requirement, create a separate capstone course for our data science majors, and then possibly introduce a data science minor moving forward.
Great, thank you very much. We have some time for questions, and I see people are anticipating that, and they have already been entering questions for you. So one of them is, can you elaborate on the 2 new statistics courses in terms of the content?
Yes, so these courses, a lot of when we examined the data, the statistics courses, we thought that they looked very much theory-based. And these 2 new courses are more applied based. So mapping the theory to more application and focusing on, Bayesian probability concepts, illustrating the application of the different theory that students examine. So we felt that these were really important for our data science majors.
Great. Another question here is, how many courses of those 42 units that you listed in earlier, how many courses are students taking that are actually sort of labeled data science courses?
So currently, the courses either exist in computer science or statistics. We don't have any data science specific courses. We do envision that changing moving forward to roll out this program sort of, even though it was not a quick process, but to roll out the program, the courses either exist within computer science or statistics. And so they're open to our computer science major, they're open to our statistics major. So they're not necessarily labeled data science, but have a data science focus.
There's another question here, which might go to several other people who've already spoken as well, but it says, in terms of secondary mathematics, what foundational knowledge should students have when they enter a data science intro course? Now, I don't know, Miriam, are you in a position to be able to answer that question? It was typed in sort of right as you were starting, so I don't know if it was meant for you.
I think it depends what is meant by a data science entry-level course. So currently, for us, we have a course called CS 105, the data analysis methods that we introduced for our major. And this is, students usually take a few math courses. They would have taken their calculus and some prior programming courses before they take this data science course. So it may be different for different programs. So for us, it requires some foundation.
Great, and I think many of the questions now appearing in the chat are going to be great questions to ask for everyone, or ask of everyone who is giving a presentation. So why don't we at this point move on to our last of our 4 presentations, and that will be from UC Irvine. And Mina, I've never been able to pronounce your name correctly.
I'll get it, don't worry, Nat. Thank you. Hello everyone, my name is Mine Doğucu, and I'm an assistant professor of teaching in Department of Statistics at UC Irvine. So many of the speakers have raised the logistic issues regarding data science programs, the infrastructure programs. So at UC Irvine, we've actually been quite lucky with this, because even before, like when the statistics department was founded, we were actually in the same school with computer science. So the School of Information and Computer Sciences actually has 3 departments: computer science, statistics, and informatics. So this school has obviously been the natural home for the data science major. And we've had this program since 2015. And currently we're at 157 students, and about 65 of them are seniors. And I would say that our major form of recruitment of these students currently is students, even though I don't have data, but the feeling I have is students switching from computer science. And I say I don't have data because I'm relatively new in the program. I should mention that as well. Can we switch to next slide, please? So while I'm presenting the courses, I'll also try to mention some of the questions that were asked already to give some idea about our coursework. So our program has quite a lot of requirements, both in computing and statistics. It's really computer science and statistics heavy. And I've put a short link, bit.ly/UCIDS, for full list of courses if anybody is interested, but I'll mention a few aspects of it. So we have in statistics, we have a year-long sequence for probability and stats. And we also have statistical methods, that's a year-long as well. So it's 3 quarters for us of prob stats and methods. And then new course that we have developed is the Stats 68 Exploratory Data Analysis course. So this is a little bit different than a typical introductory stats course. It's more data science, so it's more computing based, but it's at the same time doesn't have inference or anything that you would typically find in an introductory data in statistics course. But it's also a little bit slightly different than a typical course like a data 8 course, because this is again targeting data science majors. So in addition to topics like data visualization, we also would see something like simulations in those courses heavily, but not just bootstrap sampling, but actually writing optimal functions and so on. So this is sort of like a introductory data science course, but specific to data science majors. Because we have a separate introductory data science course that you don't see here, that's just for the general student body, which is just introduction to data science. And in statistics, I think that one thing that's unique in our program that I rarely don't see in other programs is Bayesian statistics that is required, actually, not elective. So that's something, if any of the attendees are interested in picking up conversation on Bayesian statistics, I would be very happy to. And we have machine learning. And perhaps while talking about statistics, I'll mention the previous comments about math requirements. Even though you don't see the math requirements in this diagram, we do have calculus, linear algebra, we have Boolean logic, and we have discrete math requirements. But for students coming out of high school, so they could come directly, usually students, of course, come in with calculus, but we don't necessarily require, for our introductory courses, they don't have that requirement. And our computer science requirements are actually much more in number than statistics, and I'm only showing a few of them here. And some of these are actually electives, not necessarily required courses, but students really get a strong training in computer science, including like software engineering and typical programming courses. And we do have applications. Somebody asked capstone, so I'll try to mention the capstone course in detail. So our capstone course, which is our main application course, is not taught in our last 2 quarters of our senior year. And it's jointly taught by a stats professor and a CS professor. And not only that, actually, it's not taught by any CS professor. It's always taught by a CS professor from the databases group. And I will come back to talking about this course later too, but we have industry partners and academic partners that we work with during this course, and we get data from them, and students work on their data. Next slide, please. So one of the challenges we have is because we have so many requirements, actually, I don't know the exact number, but it's quite challenging for community college students to transfer into our program. And one of the challenges we face has been definitely recruitment, but that's mainly because we are a relatively new major. And I think that can be a challenge for any new programs. And we've been seeing the timing of the capstone courses, which is in senior year, as a challenge, because capstone courses are a good way for students to make connections with industry mentors. And so that sort of opens the relationship between the student and the industry partner. And it would be great to have this course in a junior year, because that can really follow with an internship at that specific company. But at the same time, it cannot be in the junior year, because junior year is the year that they do their stats methods, they do their machine learning courses. So they're not really too mature enough to take on a full capstone project. So that's a dilemma we have regarding the curriculum. And for graduate school applications, I'll mention that I think the challenge is being for any interdisciplinary program. We've not had any students not go into the graduate school that they wanted, but I think in the short term, data science programs face this challenge, because those who graduate, if they want to go into PhD in CS, they don't have enough computing background. If they want to go into statistics, they're not too statisticky enough. So they're somewhere in between. So this could be a challenge for any interdisciplinary program that we run. And our long-term aims is definitely focused on recruitment and focusing on definitely underrepresented minorities recruitment. And as we are not at our capacity at the proposal we made, so we are still interested in recruiting more students, but that also means the planning for scaling courses, increasing caps, or offering more sections. And we are definitely working on strengthening our industry relations.
Great, thanks, Mina. So at this point, let's just open it up for questions for all of the speakers. But if you want to direct it to a particular person, that'd be great. And I'm going to start by directing a question to Mina, but I think it's actually many of you, like Mike and Justin. I can't remember if Riverside also has a capstone, but I'm just curious if the capstone is a limiting factor to the growth of your major, just to have enough faculty to supervise capstone projects. Mina, do you want to take a crack at it?
Sure. I think as the major is growing, definitely capstone course is the most challenging one to grow. And as I mentioned, we actually, 2 faculty teach this course simultaneously. So it's double the staffing that we would need. And as I mentioned, even in terms of staffing from CS, we actually get specifically from the database group. So that requires even more human management aspect. So I think capstone course definitely is the biggest challenge in growing the major.
Great. And Jamal, you had your hand raised way back in the beginning. Would you like to ask your question?
Well, my question was for Justin, and I think we can talk. But of course, we're going to have the panel for community college, and we're going to be talking about the concerns that community colleges have. And of course, my prejudice about being in computer science area. My main concern is if we can eventually come up with the courses that we can transfer from community college to universities. And I see, and I'm really appreciating for everybody getting involved with this, and this is a very good thing. I'm very happy about it. But our problem, and I'm pretty sure we're going to address this sooner or later, is if my students wants to go to UCSD versus UC Berkeley versus UCI, they might need different types of courses. And it's going to make us very, very hard to say, okay, you take this series course or this series course or that series course. And I'm hoping that one day somehow we're going to come up like, we have data 8 or data 10 that's going to be transferable to all UCs for the data science, and having a series of courses. The one that's closest to me is the one that they have it in UC San Diego, because I'm in the computer science type of thing, that you take this like a ADT that they're talking about in Cal States, that you take this series of course, you can transfer to data science no matter where you're going. Is that something that UCs are going to be talking about it, or is it something that I just take it to my grave?
I can say that it's something that we are definitely interested in trying to partner with community colleges and trying to solve. I think in part, San Diego and Berkeley having courses that are very similar could easily begin to partner around articulation. And there was an earlier comment saying that, El Camino College has now been, the transfer works for both UC Berkeley and UC San Diego. And I think that that's something that we really need to work on.
Thank you.
Yeah, so we also have folks here from UC Davis and UCLA, and I wonder if they would like to say anything briefly about, I see Rob, you put something in there about your capstone project. Do you want to mention anything on that, or about your high school introduction to data science program?
Yeah, thanks, Deb. Thanks for the opportunity. Caught me unawares. So
yeah, I'm cold calling.
Yeah, I had to find the mute button really quickly. So yeah, I'll talk about the high school program first. Suyen is also on the call. She's the director of the program, and it's a high school introductory data science program. It uses R, and it teaches a combination of programming and statistics, applied statistics, I guess you'd say. Very project driven. I think, one of the interesting features about it is, and I don't know how many people are aware of this, but the UC's changed, UC's changed its policies officially this year, so that now a statistics or data science course in the high school can count as one of the 4 years of the math requirement for UC and Cal State admissions. And one thing we hope to see from that is many more students coming to the UCs and Cal States without calculus. And I say we hope to see that because there's been a big diversity bottleneck by mostly by the Algebra 2 requirement. And I think that's a real challenge as we're designing data science majors, to think we may have lots of students graduating high school, really excited about computer science and statistics and data science, and yet without the calculus to begin their studies. And it would be great to be able to use that enthusiasm and the very sophisticated reasoning a lot of these students have that just isn't, oh, and Monica Lynn's here too, great. She can answer all the questions you see. Yeah, that aren't recognized as sophisticated because they're not mathematical, but yet are really quite sophisticated. So that's the first point. The second point is, yeah, we have a stats major that we've had for about 15 years that I'll claim is not too different from a data science major, and in part because our stats program was strongly influenced by some advisors from UC Berkeley, like Leo Bryman and all, who really kind of influenced the beginning of our program in a more data scientific direction. And so we've been running a capstone program, and as Mina says, it's quite a challenge. It's hard to get. It takes constant vigilance. I think it's vitally important, but it would be really nice to find a way of universally sharing the burden of all of this. And the last thing I have is a very editorial comment, which is, as I'm looking at the lower division, and this is maybe a question for the people, as I'm looking at the lower division offerings, I'm kind of struck by how intense they are and how targeted they are. And part of me hates to see that, because I believe lower division should be as general and widely applicable, in the liberal arts education as possible. And an advantage of the generality is it helps transfers because, it shouldn't be that there should be only one introduction to data science course that transfers. We should be general enough in our offerings in the lower division to allow different flavors of that. So I'll just kind of leave that as an editorial comment for the panelists or any others. Thank you, Deb.
Yep, thanks, Rob. And I see that Pamela, we're coming up, we're supposed to stop right now, but I see that Pamela just put a mention in about the UC Davis new data science major. Do you want to take 30 seconds to advertise your upcoming approval of your program?
It's still in the process of getting approved by our deans and our chancellor, so I think it's still a little too preliminary, but I will be sure to share once anything official comes out.
Great. And so thank you, everybody. We'll wrap up this session by looking at this great chart that Eric has produced, which is being able to compare the four we heard about, plus Berkeley's various data science majors, and you can sort of see their difference in sizes and various aspects of their program. And at this point, I believe it's time. Eric, is it? I'll turn the floor over to you, but thank you to our panelists for their great presentations. And
yep, great, thanks everybody. I think having this slide deck and this sort of last page, and I don't know exactly what the final output is, but like generating this knowledge of what's happening in different places is useful for a bunch of people. Like a specific agenda item for this group is helping with articulation pathways and what community colleges could be doing. So this is a really useful thing for that, right? There's number of people in the group that are interested in lower division math. So this is really relevant to like looking where we can compare that. Yeah, Monica Lynn said hi in the chat, and Rob Gould showed her up, but just to say there's somebody from UCOP who's here who helps with transfer articulation. So maybe this group over time could help, could coordinate with her, and how could many community colleges work on transfer articulation at the same time instead of the current system where it's awkwardly a one-on-one system currently. And if there's some way that we could help figure out as a group, that would be really interesting. We are gonna restart at 3 o'clock, but we did put a little time in here for a break. So if you have the stand up from your computer or wave your arms or stretch your legs or do something, take 3 minutes and stretch your body and stand up. All right, starting to come back to the group. Do we have Rukmini here?
Yes, you do. Can you hear me okay?
I can hear you. I can't see you though.
Oh, there you go. Can you see me now?
Thanks.
Okay.
Great. Yeah.
Do you want me to get started?
Yeah.
Or wait?
Ready. Let's just give people a second to come back in. And I'll do a really brief presentation. And I was just my screen sharing turned off, so I was like taken aback for a second, but it was time for that to end. Everybody will be sharing on their own right now. Rukmini, do you need to share, or are you just going to talk?
No, I'm just going to talk. So
okay, Rukmini's here from Microsoft Research. Microsoft has helped fund our efforts in the national workshop and in getting this some of these collaborations going. I will say that Microsoft is interested as a company to support community colleges, and so we also are working with them of like what are different platforms in the Azure space that could support data science education. But here we have Rukmini Iyer to talk about a new program that she's considering starting as well.
Yeah, so I'll give a quick introduction of myself. I'm a corporate vice president at Microsoft, and I run an organization that works on search and search advertising. And search, as you know, is pretty much an AI space. And going back, I graduated from BU with a PhD in what was then called statistical modeling, because we didn't call things AI or machine learning. And so I've been in this space for about 20 plus years now, and I've seen it evolve over time, where it was very heavily focused on two camps: statistics and people who use data for modeling, and into now where all these areas are kind of blending together and falling into kind of pretty much in data science. Everybody says data science, but when you look at the space of data science, it has wide applicability. It's not really only about deep learning or neural nets or what you hear in the media or hovercraft cars and self-driving. People are using data science for day-to-day. They're using it in climate, agriculture, like pretty much any area that you think of. So that's one. I also want to give some brief background on myself, that I have two kids who are in the UC program right now, one in Santa Barbara and one at UCLA, and neither of them chose data science. That's how it goes. If your parent is in the field, you don't pick the field. So one is in physics and the other one is in neuroscience. But I see them both use data science and Jupyter notebooks and Python programming. And I see that that's because these universities have been adapting as they go along, realizing that these skills are much needed. So thank you to the UC system. As you adapt, the rest of us in the corporate world end up with the benefits of students that you train. And one of the reasons I'm here is because of the students that you train. So when we hire from the data science community, so far, we have been exclusively looking at master's and PhD programs, because there wasn't really a data science program in many of these universities even a couple of years ago. And so we got people from computer science who had done some statistics, or we got people from statistics who didn't know some computer science. And so we were always in this awkward position of what do we do? Like we either have to, it's easier to, what I've learned is it's easier to teach a statistician computer science versus the other way around. So we used to focus on the master's and PhD programs and get students from there. But given how many data scientists we need, it's just impossible to just look at the graduate programs and get candidates from there. So we really need to start now looking at the bachelor programs and see who's coming out, with a strong foundation for data science. And one of the things that I got involved in early on is, and Karen and Caroline, my colleagues, are here from BIDS, who will talk about the Women in Data Science program. And we started with, saying, can we get people interested in data science, high schoolers? And we quickly realized you have to go not just to high school. Somebody in this forum mentioned about how, even in high school, you get women or girls interested in data science, and then they see that if they want to do data science in colleges, they have to either be in the computer science department. And now, luckily, you guys are actively thinking about the data science pathways for these women. And then the second is the requirements. I think we really want strong data scientists. So ideally, they should get a very strong foundation in statistics and math. But once you miss that in your high school window, then you're behind the curve. So by the time you get to your first year in college, lots of things are already not available to you until you catch up on that math pathway. So what the community and state colleges are looking at in this program, I think eventually we are going to have to push this down even more into the high schools before we actually have a foundational pipeline, like how we have a foundational pipeline for physics, computer science, and other areas. The program that Eric was talking about is how do we, as a corporation, how do we influence what's going on, or how do we give you the feedback as to, hey, you graduate, these excellent students, they come to work with us, and then we see some skill sets missing. How do we communicate this back to you? Or another way of looking at it is, how is data science actually used in Microsoft? I'm telling you that it's used everywhere, but if you want a visibility into how we use it and at what depths we need the statistics foundation, or at what depths we need the computation foundations, how do you get a visibility into that program? So what we're thinking of is trying to see if there's like an internship type of a program where some of you, join Microsoft for 4 weeks as an intern, and you follow us as we study, as we, you go through our machine learning scrums and our modeling scrums and our experimentation and flight rooms, where we run flights and we check how do the metrics look. And that gives you some visibility into the core depth of statistics that students should ideally be equipped with when they exit from your programs. Now, this is a 4-week, and we are flexible about when the 4 weeks can be scheduled. Like, should it be right after school ends, or you're just tired of doing things? Should it be just before school begins? So we are completely open to how to flexibly schedule it. And luckily for us, it's COVID, so it's all remote. So you'll join, and so we've tried this program last year with the University of Washington, and apparently it was very successful. And so we're thinking, I'm based in the Bay Area, so I really want the California community to participate. And so that's the proposal. So if there is interest, if you can let Eric know, and if there is real solid interest from this community, then I can go put together the proposal with Microsoft and come back to Eric and say, hey, these are the 4 corporate spots available for you to try. And because I'm based in California, obviously, once we can do things in person, we have a beautiful campus coming up, so we can also do this in person. So thank you, Eric.
So
thank
for
you
now,
for the
email
time.
us, and we will probably set up a form, and we will triage and send the applications to Rukmini if you're interested in that sort of data science instructor internships. I read about the one in Seattle, and it sounded like a really great experience for those people. They had done one with somebody at UW who was like a high level researcher, and one with somebody that was like at a, more like a teaching college. And so that they had some from different backgrounds.
Right. And they're planning to continue that program in Washington, up in Washington.
Okay. Thank you.
Thank you.
All right. Can we hear a little bit about the WIDs?
Sure. Can you hear me okay?
Is Karen here? Hey, Karen, there you are. Sorry, there's too many people. I can't see you on my page. Karen Mathis going to tell us about WIDs from Stanford.
Sure. And let me share my screen if that's okay.
Yep.
Actually, it says I'm host disabled.
Let me add you.
Thanks.
Yes, you should be able to.
You're now
right
able
now.
to share.
Okay, excellent. Let's see. Share my screen. Let's see if that comes up. Can you see that okay?
Yep.
Okay, excellent. Well, thank you, Eric, for having us speak for just a few minutes. I'm Karen Mathis, and I work at Stanford in a program. It's a degree granting program, ICME, that really sits at that intersection that Rukmini was just talking about. The program is interdisciplinary, and it's the intersection of math, applied math and statistics, computing, and very application focused. We actually have a data science track. We do that with the statistics department at Stanford, and we're very keen on building a stronger pipeline from all of your schools, particularly in the diversity areas. I don't have time to go into it today. We're rolling out some new programs there, but I'd love to continue the conversation about that. But today I wanted to talk about the Women in Data Science Conference, and Carolyn Bauhaus from our team is also on the call. And Rukmini has also been very involved since the start, as well as Microsoft has been overall. And so, okay, I just have a few minutes, but I'll give you some quick highlights about what we're doing and how you all might want to be involved right away or later on this year. So we started this new initiative, now it's been 6 years at Stanford, and we started it as a technical conference with a twist, basically featuring 100% women speakers in academia, in industry, in government, and nonprofits, to really inspire everyone. And we started with these 3 goals. So we wanted to encourage many more women to get involved in data science, coming at it from many different perspectives. So that's part of what we always share, is there are many paths in data science. It's definitely nonlinear. And we want to encourage everyone to get involved. Second is educating everyone. And we invite all genders to attend all our events. And we share a lot of really exciting new technologies and application areas in data science. And third, we want to support women in the field, whether they're just starting their studies at a college or university, or they're a senior in academia or industry. We're trying to cover the entire range. Okay, let's see. And so we started as a small conference. Last year, I'm excited to say it's grown quite a bit since the start. We had over 100,000 people participating worldwide. Some of you may have been involved. A lot of different schools in California and throughout the world participate with us in many different countries. And coming up in less than 2 weeks is our first online virtual conference. This will be on March 8th, which is International Women's Day. And what we're doing is providing 24 hours of coverage of live talks, as well as workshops on topics you might be particularly interested in, like data visualization, data ethics, and so forth. Lots of opportunities to meet the speakers and also to network. If you're there from UCLA right now listening in, we have Andrea Getz, who just recently won the Nobel laureate. Professor Getz is our opening keynote. So we're thrilled about that. And then the closing panel will be on the future of data science education. So those are just 2 points where I think you all might want to join in, but throughout the day. And the registration fee is only $49. We're keeping that fee for until March 7th, actually, the day before. And if that seems too prohibitive, I'm thrilled to share that we have 10 VIP passes for this group, for the California Alliance. And I can share a link after I talk in the chat. So for the first 10 people who sign up, put your name and email and school, and we'll give you the link so that you can sign up for free.
Nice.
Yeah, we're really excited about that. And of course, we'd love to hear your feedback. This is our first time doing it online, and it is a huge endeavor, but I think it's coming together really nicely.
Great.
So other ways you can be involved. A lot of schools host their own WIDS events throughout the year, and we call the organizers WIDS ambassadors. We give them a kit of materials to make it as easy as possible to host your own event. The deadline for this year has already passed, but keep that in mind for next year if you're interested. And we have some other initiatives, and I'll touch on them very briefly, a couple here that I think might be of particular interest. One is that we do a datathon, and I think this is especially great for undergraduates who want to learn the basics of predictive analytics. And the focus here is on the collaboration and less on the competition, but it is a competition. We hold it on the Kaggle platform, which some of you may be using already. It's pretty easy to get on board. We always do it around a social impact challenge. And we insist that there are at least 50% women on the teams so that women really feel like they've been involved and belong on the teams. A lot of schools hold workshops and mentor students, train them, help them form teams and that sort of thing. So it really is a nice, fun workshop that these schools are rolling out. And again, this is something particularly for next year you might want to consider. The latest initiative is our WIDS educational outreach, where we realize the great need to go deeper in the pipeline, like Rukmini just mentioned. And so we've taken the best of WIDS and we're tailoring those materials to make them suitable for younger women and girls. We started piloting it with high schools, but we've realized quickly that it's very relevant to undergraduates and even younger students as well. And all of these materials are available. You can link on our website to these materials and check them out. I think we've gotten some really nice feedback, particularly about the videos that we're doing that highlight women on the job, young women doing really cool things. Like one young woman is in Spotify, one's doing marine biology, one's in government, just showing there's many different paths you can take in data science.
Okay, Karen, we need to move on. Can you wrap up?
This is it.
Okay, great.
Last slide. Here is our just please join us. I hope you can find some way to participate. And if you have any questions for me or Carolyn, here's all our contact information. And we just look forward to working with you all in the coming year.
Thank you. Awesome. Our students love WIDS.
That's great. And I'll just share the link now if you want to sign up.
Fantastic. All right, moving on to our panel with starting with community colleges. I think Katja Fuchs is first, talking about what's happening at CCSF, a big, exciting partnership that we've been working on for a while.
Hi, everyone. So I'm going to share my screen. I've prepared a small presentation. So I think this is the right screen. Okay. Okay, so when we are talking about building a data science program at a community college, one of the main pieces is training faculty to be ready to teach these courses. We don't have data science departments at community colleges. We often don't even have statistics departments. Some community colleges do. At City College of San Francisco, we don't. We have a math department and we have a computer science department. So as somebody who believes deeply that this is curriculum that we should be offering, we are thinking about how do we take the faculty we currently have and expand their knowledge base and train them to be able to teach these courses. So we have our first cohort of training started now, and who is going through it? So again, this is our first cohort. We hope this is the first of many. So we have two faculty leads. They are both here with me. I want to acknowledge them as my partners and great friends in this endeavor, Sean Wiggins and Craig Persico. Sean Wiggins is a math faculty member and Craig Persico is computer science faculty. They have gone through the Data 8 course at UC Berkeley, and they've been working intensely to develop this training program. Going through the training itself, we have 3 math faculty. I believe a couple of them are actually here now, Ronald Page and Amy McClanahan, and 3 computer science faculty. I don't believe I saw any of them here, but we do have 3 computer science faculty and 3 math faculty going through the training. One thing that I think is fairly unique about our training and something we're pretty proud of is that we're also training 2 classified tutors. We are training them to really look at it from the point of view of where are students going to have questions, where are students going to struggle, where are we going to need to support students when they start taking this course. So we are actually having them go through the Data 8X modules and give us feedback, and I'll say a little more about that later. So everything being remote, our training program is in Canvas. So I put a little screenshot there of what they are looking at. So there are 16 modules total. Module 0 is where the faculty training is really focused. It's comprised of Python Quick Start, how Data 8X quote works. So how does one teach? What is the pedagogy in Data 8? It's a slightly different approach to teaching than perhaps a traditional statistics class. It's more of a flipped classroom idea. Working with Jupyter Hub. So City College of San Francisco has a partnership with 2I2C that gives us access to Jupyter Hub. So faculty who are going through this training are going to be able to log in and access it and build and play with Jupyter notebooks. Working with AutoGrader, specifically AutoGrader, and of course, working with GitHub. So that is the faculty training piece. And then modules 1 through 15 are Data 8X modules. So we are very fortunate in that we were able to secure a small amount of funding to be able to actually pay folks to go through this training. It's a small amount, but it's better than nothing. So faculty who are working in this training are paid for 13 non-instructional hours of time. So that is for faculty. And then for our classified staff, so I will say a little more about them here. So these are professional tutors. They are classified staff at City College of San Francisco. And in addition to their regular duties as classified tutors, where they are, working with students, they are embedded in other courses, they are being paid 2 hours per week to go through this training. So what they have been advised to do is they have been advised to sort of aim to go through 1 module of Data 8X per week. I think I say more about this a little bit later. I may come back to this. Part of doing this training is about building community. So faculty and staff who are going through this training will be meeting periodically to discuss the training experience, kind of where are their questions and so on and so forth. So we're really focused on the fact that this is something that we will build community and kind of engagement around. This is not just folks going through training on their own. Classified staff are asked to journal about their experience, specifically from the student angle. We've designed this course to be open access. So students who don't have the prerequisites to take, for example, a calculus class are able to enroll in this course. So as our classified tutors are going through this training, they're asked specifically to pay attention to, where are there examples that maybe we need to modify because of the background that our students may or may not have. So for instance, if there are examples that are heavily focused on trigonometry, we should probably modify those. If there are examples that involve a thorough understanding of logarithms, we should probably modify or support those. So really asking them to think about where are students going to be having those questions and concerns and where do we modify it. So for our next steps, we intend to offer 3 sections of Math 108 in the fall. So our sections are roughly 35 students. So this is very much a pilot program. We are not offering dozens of sections because we don't know if there's demand. And also we are working on that articulation and articulation piece with the Cal State and the UC system. So we definitely hope to expand this, but that is our plan for fall 2021. Moving forward, as we create a growing community of Math 108 faculty, which is our version of this course, we hope to continue to maintain this community of practice, really kind of developing interdisciplinary partnerships, not only between math and computer science, but possibly beyond. So that's all I have. There is my name, and feel free to contact me if you have any questions.
Yay, go team. It's totally gonna happen. Thanks for everybody at CCSF for leaning into this awesome project. Next up, our other heroes, Solomon Russell and Alice Martinez from El Camino College, currently piloting Data 8 right now.
Woohoo!
It's you know, and don't let me I don't want this to sound wrong, but if you guys come to the summer workshop, you can grow up to be like these guys.
That's so nice of you to say, Eric. So can everybody see my screen? Everybody's good? Great. So my name is Solomon Russell. I'm a professor at El Camino College in the computer science department. I'm going to be giving this presentation with Alice Martinez, who is a professor in the mathematics department. We're both a part of the mathematical sciences division at El Camino College. This is a picture of our website that we put together. We'll be talking a little bit more about that later, and a little biddle at the very bottom if you want to find it and see some of the cool things. So in this presentation, we're going to be going pretty quickly through a number of things so we can concentrate a little bit longer on infrastructure. We'll be talking about the creation of our class, how we advertised it, some of the pedagogy that we're currently going through, and then also some of the infrastructure. So how we started this class, we first started teaching BJC, the Beauty and Joy of Computing. That's a class based from Berkeley. Because of that class, we found out about data science. In 2019, we held information sessions. Alice, myself, and also a student that had some experience in data science, Topher Allen. One of the first things we did is we came up with a data science plan. So we decided to put together a plan where we looked at what were the current offerings of data science around LA and around California, where we could help our students, and what pieces that we could fit. I'm really excited about this. So we were really worried about starting a new class in the middle of a pandemic. So that student, Topher, who happened to take Data 8 in the summer of 2019, he's been amazing. He works with ASO. He was able to get us this on Canvas during the winter session when no other classes were up on Canvas. So as soon as students logged in to see their grades, they saw this advertising, not just for our class, but also for the data-driven persuasion class that's being taught out of the communications department. Independent of our work in Data 8, there was other data science initiatives going on at the college that we found out about. In the top right, we put out is a picture of a press release we put out as a school. And then underneath that, because of the press release, we went on local TV. That was me and three other students talking about data science.
So there are 3 professors and 2 volunteer tutors that we are working with. So Professor Chanji is a part-time instructor, and then Professor Russell and I both work in the mathematical division, but I'm a math professor. I usually teach statistics, and he's a computer science instructor. So we got that variety so we could cover the different topics. And Topher Allen, and we also have a tutor in our tutoring center who is also helping out. We started with 2 sections this spring, and then we were able to open up 2 more. We almost opened a 4th one, but a 5th one, but we stopped at 4 because we wanted to be sane, especially with the first time through. So we have about 80 students. We're actually teaching it in a team style. We only have 2 lectures, and then we have 4 separate labs. So all the students come together in either one of the 2 lectures. So we're able to team teach it. We're really enjoying the team teaching, especially having computer science and mathematicians in there, being able to teach their different topics that they know more about. It's been really helpful, and we want to figure out how to utilize what we learned from being online, being stuck to being online, to how we might be able to do that again in the future, maybe keep just the lectures online so we can team teach and then have the labs separate but still in the classroom. We're also using Piazza. Topher Allen is helping us a lot with that to help the students be able to crowdsource help, because one of the biggest things is how do you help all these students when you don't have a lot of people in your tutoring center who know about it. So next slide. Next one. Okay, so we were given this out-of-the-box Canvas site from Berkeley. We are really grateful to have all of that material. We pared it down to what we were going to use this semester. This is basically the edX module, and we decided we were going to teach ours more where we actually had lectures and then did our lab, since we have lab time for the students, work with them in the lab time. So we took away all of the videos and stuff. And next slide, please. Our main page looks like that one kind of at the top, but on our page, we mostly just have links to the textbook, the lecture notes, the lecture slides, the homeworks, and the lab assignments, and the discussion, since we're in an online format. So our Canvas site looks a little bit different because we decided not to use the flipped classroom method, but to actually have lectures via Zoom. Next slide. You're muted.
So one big issue when we first started thinking about data science, the biggest one is how are we going to learn this to teach it? The second one was how are we going to provide the environment for our students? So at first we started thinking about, hey, we're going to get our own server. I contacted IT. I talked to then Eric Van Dusen, and he said, hey, we might be coming up with a solution, and this is 2I2C. The great thing about this is that we're not tied into anything. All the different solutions that we were thinking about, maybe in a year, 2 years, we might have been locked into this. The one great thing that is continually voiced to us is that if you want to change, like say cloud providers, you can do that easily. If eventually we want to run our own server, 2I2C will help us with that as well. This is what it looks like when we go to the El Camino login page. And on the right is a Jupyter lab. This is actually a notebook that we had from some of our students just doing a couple days ago.
So we have just barely 2 weeks into our semester, but our students, we asked our students to respond. We told them about this meeting and asked them to respond so they could tell all of you about how they were feeling. So one of the questions we asked was how easy it is to use Jupyter. And you can see we had about 78% who were fairly happy with the use of Jupyter. We definitely had a few glitches. We've had some weird glitches, but overall it's been, we've had people working the first day in lab able to get into Jupyter. A majority of them were in Jupyter working on it, coding. So next. If you look at the majors, there's a very nice variety of majors similar to what you'll see from the pictures from Berkeley. A couple of those, it's a little deceptive because we didn't get around to fixing the fact that undeclared and undecided are really the same thing. And the person who wrote ideally, da-da-da-da. But this gives you an idea of the variety we're picking from, that join the course. And so we're really happy to see that we're getting students from all across the campus. We asked the students to give us some quotes and told them we would cherry pick some answers. We liked these 3 answers. Basically, they liked the fact that was available here. They're amazed that we even have it. And I like the last quote, because of its affordability and my familiarity of the field, I'm taking this course to add to my skill set and prepare for me as a tech career.
So what are we doing next? We're currently thinking about developing more classes, trying to figure out where we can actually help our students and what additional skills that they need. We're planning a 2021 Data Science Day. We're also already planning the 2022 Data Science Day to continue advertising these new classes. We currently have 6 sessions that we're scheduling for fall. That should be about 120 students. We really filled up our 4 sections this semester pretty quickly. So I think we will probably get to this 6 sections without too much trouble. And we're also thinking about partnerships with community colleges, Compton College, we've reached out to. They're just starting their computing program, so we are going to partner with them to hopefully bring data science there and do some professional development. Okay, thank you very much.
So great, so awesome. And Topher, is Topher here? We need to have like a Topher.
Oh yeah, we can't promote him enough. We're so grateful to have him. So
that's so cool.
I'm here, just having a great time. Happy to help.
Awesome. Okay, moving on to the CSU. Starting off with CSU Monterey Bay, we have Judith Ganner and Nathan Jue to talk about their biology and data science.
Thanks. Yeah, and it's last name's pronounced Jew.
Jew, Nathan Jew. Nate Jew.
It's okay. So let me share real quick here. I'm going to be talking about something that's a little bit different because it's not going to be data science exclusive. So I'm in the biology department at CSUMB, and I'm going to be talking about some work that we've been doing to integrate data science into our biology major, which we hope will actually play well with a lot of things that Judith has been doing to build up data science curriculum in that's sort of more broadly related to people that accessible to people at CSUMB, particularly a data science minor that has just started up. So we hope this will become a nice pathway to get students into that. You know, I don't have to tell you guys a lot of stuff, but you know, we have seen sort of these trends in workforce development, and at CSUMB identified that, you know, there are this need for biology students who have sort of a contemporary skill set, right? Who are not just biologists, but actually are able to work in data science as well. And we've seen this come out numerous times in numerous ways, but this is just one example of some people who've identified this as being important to them. And so as a faculty, we looked at that and said, well, we really need to try to contemporize our major to try to integrate more data science into it. And to do that, what we decided to do was to sort of target two aims. One is I'm not going to talk much about it, but we're actually working right now to develop a dedicated pathway for students to focus in a more data science oriented field. And so for us, data science is easiestly conveyed for biologists as bioinformatics, right? But it's not just bioinformatics, but it's kind of the one that we've used as sort of like the overall thematic approach in order to sort of coalesce everybody around the same idea. So genomics and bioinformatics is that. But we at CSUMB, we put a lot of emphasis on course-based research. And so we decided that taking a cure approach would be a really meaningful way for us to try to vertically integrate this skill development across our curriculum. CSUMB is a pretty young institution. We've only been open since 1995, and our biology program's only been around since 2007. But we support a lot of low-income, first-generation, and underrepresented minority students at our institution. And there's interdisciplinary sort of built into our core and our mission and our vision statements. So, you know, it's a really interesting place to work and a really interesting place where we can make an impact on students and provide them some excellent opportunities. So we were really excited about this idea of contemporizing our major to make our students more competitive as they moved out into professional fields. And I'll point to here that this genomics and bioinformatics program that we're hoping to get up and running, we're targeting for actually starting it in the fall of 2022, if everything works out. I still got to get it through university. So what did we do? Well, we decided to vertically integrate these cures. And so the approach was to integrate, sort of focusing here on objective number 2, is to integrate data science across our biology curriculum by developing and implementing new cure modules. So understanding that research is a high impact educational experience, educational practice, we thought that this would be the best way for us to build up these practical skills in data science. And we wanted to apply sort of this process of introduction, development, and mastery across our curriculum. So we took some basic principles. We wanted to make sure that we were supporting faculty interests specifically, so people would stay motivated in the project while promoting collaborative work. We wanted to treat each of these modules as a true research experience to improve its impact on our student science identity. And we then also identified some core competencies that we wanted to focus on. So these come from the NIBLS RCN, which stands for the Network for Integrating Bioinformatics into Life Science Education. And we had our faculty rank these core competencies. And what we came up with was about 2 of them everybody thought were important. And then there was a bunch that different people thought were important. So as an approach, we said, well, as you're going through and developing, these modules in data science, focus in on making sure that you're emphasizing one of these top 2 and at least one of the other ones. And so at the 100, 200 level, we're introducing these concepts. At the 300 level, we're developing these concepts. And at the 400 level, we're trying to get to some sort of mastery of these concepts. So that was our approach. And everyone, we were able to come to an understanding with this large group of faculty, about 16 different faculty and staff, on how to approach this. What this looks like in terms of curriculum is that we ended up with different layers. We have our 100 level courses, our 200 level courses, our 300 level courses, and our 400 level courses. These orange ones are all capstone courses, so they're more project-based courses. But we basically built in course-based research experiences to the majority of these. Right now, the ones in red we've all finished and have implemented. The ones in that teal, we're still kind of doing some development. We had some faculty turnover, so we had to sort of restart a couple of them. And a few of these lower division ones, these first year seminars, we're still trying to get through our university GE, so our general education committees. But overall, we've done pretty good. Some of the preliminary outcomes, just so you can see what it looks like, we've seen when we assess sort of student identity using a tool developed by one of my colleagues, basically at 200 level, we start to see some pretty good gains in things like motivation, self-efficacy, collaboration, analytical skills. And we see those gains seem to increase as we move up to the 300 level. If we think about pre and post COVID, if we look at our intro biosequencing lab, which has a bunch of R in it and things like that, we were doing better pre-COVID, but we're not doing terribly post in analytical schools. Maybe we dropped off a little bit in ownership. The other course I wanted to highlight that was been really important for us for data science has been this class that I developed called Practical Computing for Scientists. Probably in a lot of ways similar to what you're talking about with the Data 8 class. Like it's sort of meant to provide like base skill levels for science majors in data science techniques. And so we put an emphasis on computing skills, specifically on things like proficiency in Linux command line, object-oriented programming, writing programs and scripts, and analyzing data in Python, how databases actually function and set up. So biologists, we always put things in Excel spreadsheets, and letting students understand that like there are proper ways to data manage, and also to query data out of databases. And then at the end, getting them to complete a significant project. And I'll just mention, from like it's an interesting course that services sort of all majors at CSUMB, so all science majors. And because it's a bio class, and not a computer science or math class, I'll just say that that class is always over 50% female. So like it's not, all of our science majors are generally majority female anyway, but it's interesting to see how that kind of plays out. We've taught about 12 times right now, so it's a decent model, and I'm happy to share materials with anybody who's interested. But just so you can see kind of some of the outcomes, we've got a wide range of pretty complex projects that students have been able to accomplish using SQL, Python, multiple language platforms, things that interact with each other, whether or not it's building of databases or automated pipelines, or writing a program to track cell movement from videos, like, some really cool stuff. We've seen good gains in analytical skills, soft skills like collaboration, and we still have some room for improvement, right? So we're not pushing them into graduate programs as much as we'd like to, but some stuff for us to reassess and work on. We've had a lot of challenges. I think infrastructure was brought up in the last talk with Solomon. Like that's been a big thing for us, and also across the CSU. How do we get the kind of computational infrastructure we need? How are we going to support this financially long term? And the professional development is definitely one also. Obviously, my colleagues are all huge collaborators on this, so I want to thank all of them, but happy to answer any questions on any of the work we're doing on this or our dedicated curricular pathways afterwards. So, thanks for your time.
Awesome, thank you. All right, I'm gonna keep going and save questions to the end, but feel free to put them in the queue in the chat. The next talk is Iona Chatterjee from CSU East Bay.
It says I can't share.
Nope.
Oh, I can. Hey. Hi, everybody. Great to hear all the different talks. I'm going to talk about what we've been doing at Cal State East Bay. I hope to give a little introduction as to who we are, what our campus looks like, our courses, what we offer, our current concerns, and then, of course, our takeaways. So CSU East Bay is actually located in Hayward. We are just 20 miles south of Berkeley. Our population, though we are geographically really close, our student population looks really different. I have a little snapshot. This is from the data warehouse. It's public. Everybody can see it. We have about 16,000 students, but almost 60% of our students are transferred. So that's something we always want to keep in mind. We have a large first-gen population, just like Monterey. We also have a very diverse background. We are classified as a Hispanically Serving Institute. I'm sure there are many more here. So these are some things we keep in mind while we build our curriculum. I would also like to make a note that 50% of our incoming freshmen are classified as not college math ready. So they are offered some kind of a co-rec or a stretch course as they go through. The Department of Statistics and Biostatistics at Cal State East Bay is actually a standalone department, one of the few at CSU. Actually have 3 of my colleagues today on the meeting, Eric, Joshua, and June. So thank you for coming by. We offer a variety of degrees, both at undergrad and the graduate level. We have a Bachelor of Science just in statistics, but then we also have our Bachelor of Science in data science concentration. We offer 3 different minors, and then we have a pretty large master's program. So we have a biostats MS, we have just the MS in statistics, and then 3 different concentrations, applied stats, data science, and last one. So for today, though, I am just going to focus on our undergrad programs. So the data science concentration in the BS and the data science minor. So this is kind of a little what our data science concentration looks like. I've split it into 3 groups. We have an introductory core, we have an advanced core, and then we have our data science electives. The introductory core is basically 3 courses. They can choose between programming for everybody, which is like an introductory Python course, or Calc 1. And then these are the 2 recommended cores. The Intro to Data Science is our equivalent of Data 8. So it's very similar. So they would take that. The advanced core is the more traditional statistics courses. This is actually common to both our undergrad programs. We just do not have the logistics to have them separate. And then we have the data science electives, which are the Intro to R, data visualization, and statistical learning. Then they are encouraged, they can take 2 more computer science courses, which could be like database management, structures, and so on. So there is some flexibility as to what courses they take, but this is kind of what the general outline looks like. What I would like to highlight is our introductory core, which we call Calculus and Compute More pathway. So for only our data science concentration, we are actually offering students a way to complete the whole program without taking any calculus. This is new, so we don't know how successful we're going to be, but we really feel that this is the way forward. So as you can see over here, instead of taking the calculus, they could just take those extra CS courses and the Intro to Data Science course and move on to the advanced core. So for those who are thinking, how can you teach probability without any calculus? We offer a probability through simulation course. So that kind of takes care of that. Our linear and logistic regression is also very projects and data focused. So kind of removes the requirement of having all those calculus requirements. Our biggest motivation to create this pathway is that historically calculus has been the biggest roadblock for students to pursue our major. To give you an idea, we have only 42 students as of fall 2020 enrolled in our program. That is really small for a data science program. It's growing and we need to kind of catch up, and we really feel that that's the roadblock. We're actually working with community colleges, like most of our students are transferred. If we could create a pathway so that they can take those computer science or the basic math requirements and then transfer in to take the advanced core and the data science electives for our program. I kind of narrowed it down to 3 biggest challenges: is to increase enrollment, to get department buy-ins, and to manage competition. Our freshman enrollment, actually, even in our master's program, has been going down. It's a bunch of different issues, but we really need to focus on enrollment. Right now, as you can see, our courses are all stat housed. We have a few computer science courses, but not much buy-in from other departments. And manage competition, it's the Bay Area. It's not just external competition. In our college, in our campus itself, we have a data analytics program in the business school. So we are always competing for the same students. So one thing that we started this fall of 2020 was a data science minor. This is basically with the hope that we can introduce more students with a much lesser commitment to data science. So they would still take those 3 electives in data science, but then there is much more flexibility in the other courses that they take. And all these courses can double count. So, there is incentive for people to do it. We feel this is our foot into kind of getting it to be interdisciplinary, because we did get some buy-in from the math, the health science, and the CS department, but this is all still within College of Science. So, going forward, these are my kind of takeaways. Popularity, the data science courses are getting much more popular. We have seen an increase in enrollment. We are working on trying to get more student opportunities on campus. So we have a data science club that's run by students. There is a work group on the COVID-19 data hub that the students work on. And we feel that the minor is kind of presenting us the opportunity to collaborate with other departments. So we would like buy-ins from like English, to do some natural language processing and things like that. Incentives, of course, we would love to see collaboration with industry. The dream would be to offer a standalone data science program. And along with that, we have to keep in mind that we kind of have to keep growing, just not with students, but keeping our faculty trained and engaged as we go along. So we have the same resource problems like every other CSUs. Thank you.
Thanks. This is great. A little interesting commentary on the chat. People are interested in calculus. That's definitely something that, we know can be a filter, and, inclusion, it might mean less calculus, might get a broader demographic in. But the interesting question was, what about linear algebra? So this is certainly a big thing in data science. At Berkeley, it's definitely like you have to go, it's like linear algebra is far away down the math sequence. And I don't know, for us, there's all these questions of like, who's going to write that linear algebra class that, is just the linear algebra you need for data science, and maybe that you didn't need calculus and partial differential equations to get to that class. But I see that Josh mentioned, Eric mentioned that linear algebra is not a requirement for the major. Iona, I don't know if you want to comment on that.
So that's right. Actually, even for our BS statistics program, linear algebra is one of the electives that they can take. And And I do want to point out that, we do mention at advising that if you're going to graduate school, you do want to take that year of calculus so that you are not limited. But this is mainly focused at students for whom calculus is just a no-go. And we really do have a very large proportion of students on campus like that. So if students do want to take linear algebra, they do want to take calculus, it can all count towards their degree because we have that flexibility in electives. But we are trying not to go there.
Great. Yeah, I mean, so what, so do we need to work together to build this class and make it legitimate? That's like the linear algebra for data science class that,
That's right. So the pathway that we're working with Skyline, we have started talking about if there is a math course that would cover, instead of calculus, we could create like a catch-all everything that they could take so that when they come, they have the necessary math background.
Yeah, very interesting. Wayne's saying you could have linear algebra from regression, like you could motivate linear algebra through other things people are learning.
It's been like teach as you go, so
right.
Like little doses of stuff.
But it's also, there's also this catch-22, or I don't know, whatever, like a problem in the logic as well, where you're like, you would want somebody who was going to do a rigorous data science, at somewhere, like to get to UC Berkeley and be the transfer student, you're going to have a good data science class, to make it through some of the upper division classes. So, we don't want to make like a completely separate reality as well.
Oh, can I say something?
Yes.
Yeah. So one of the advantages of it being a small program is that, I can advise students one-on-one. So if students tell me they're interested in going to Berkeley or going to graduate school, then I definitely tell them you should definitely take the calculus and linear algebra classes. But for students who aren't interested in progressing that way, then it's not really necessary.
Yeah, for sure. Alice, did you want to say something about what you guys were thinking about at El Camino for this?
We haven't gotten too far in it. We're trying to find, sorry, let me put my video on too. We were trying to handpick some math professors that would help us create this. And then I heard that from Judith and Wayne commenting. So I was writing down their names so I could connect them with the professor that we think is interested in helping us create that linear algebra course. So we're just in the, hey, we want to do this because we want to prepare them to be able to transfer. So
I really like Rob Gould's comment in the chat that if you had a linear algebra for data science, it wouldn't be like a proof-based, show this derivation type of teaching. Like it would be like an application-based teaching.
Yeah, we definitely wanted it to not have, like they're saying, we don't want them to have to go through an entire calculus sequence to do it, because linear algebra isn't all calculus, just a tiny bit of it is. And that's what the professor we're thinking of, he's always said, why do you have to take calculus before linear algebra? It doesn't even have to be done. So.
Yeah. Here's a good one. Isn't calculus needed for upper division stats classes?
I think, we are trying to, especially in an undergrad program, make sure, especially, in regression. So we have a probability through simulation, which kind of removes that requirement. So they don't see any calculus. And I know Eric, he teaches the regression class, and even if they see it, they see very little of it, enough for them to kind of catch up. And it's like teach as needed basis is how I would put it. We're trying to scare as fewer people as we can away from the data science program.
Well, it seems to be a lot of interest in this area. Thanks, everybody. Thanks for these awesome presentations. I'm inspired. I'm inspired that young people going to college today have awesome options to do cool things. And thanks everybody for attending. I feel like we've got even more interest in what we're doing. And thanks, Solomon, for your great promotion of the collaboration and the 2I2C. If people want to know more about 2I2C, we're happy to chat about that. It's a nonprofit that Berkeley's working with that is providing infrastructure solutions in a pilot scale through a Cloud Bank NSF grant, but we're piloting how to provide Jupyter hubs at the community college level as sort of a point of vision right now. I encourage you all to come to the summer workshop in June and potentially continue this conversation right from here. And if you want to be part of thinking about what that panel is or organizing or talking about that, please reach out to me personally, ericvd@gmail or dshelp@berkeley.edu. I think people have been writing to us, dshelp@Berkeley, that are interested in Rukmini's Microsoft project. So you can write to DSHelp if you want to get, we will send out information about that. So a bunch of different things to follow up on, and we look forward to seeing you again. Thanks so much for the presentations.
Thank you, Eric.
Thank you.
Thank you.
Thank you, everyone.